Okay, so let's look at the one from today. Again, these are the ways to solve problems. 100% of the problems that you do in chapter 5 will involve one of these. You're either going to use the rules or the formulas, right? You're going to use a Venn diagram. Two-way table like you did on the homework, like on the back side of the homework. Tree diagram, which I'll show you. We'll do, if not today, tomorrow. Or more than one of the methods above. Sometimes you have to use a table and a formula, like I did here. To solve B, I needed to do a Venn diagram and I needed to do the formulas. That's what I mean by using more than one. Okay. All right. Oops, we did that. So that's our list. That's what we're going to do. We're going to come back to that. So when you're doing these problems, go through it. Have I tried this? Have I tried this? Have I tried this? Have I tried this? Have I tried more than one of those? That's what your list is going to come down to. Okay. So we're going to do more practice with using those things. Okay. Okay. So before we start a couple things. Independence. We talked about independence. Independence means one event. If knowing that one event is going to happen, it doesn't change the probability that the other event occurs. Okay, so if I know one thing's going to happen or already did happen, is it going to change the probability of something else? If the answer is yes, it will change the probability, it's what we call dependent. If it doesn't change the probability, it's independent. Okay, I roll a die and I roll a 2. Does knowing I roll a 2 change the probability that I get another 2? Still 1 out of 6, right? Those events are independent of each other. They have nothing to do with each other. They don't affect each other. But if it changes, then it's what we call dependent. Okay? So what they're going to ask you to do is they're going to say, are these two things independent? The worst thing to do is to think about it. Because when you think about it, you can kind of convince yourself one way or the other. And trust me, it doesn't work. Use this formula right there. Now that line right there, I'll explain what it means today. In the next slide, I'll explain what it means. But this is the formula we're going to go back to. So anytime they say, are these two things independent? We're going to go right there to this formula. Okay? Conditional probability. Conditional probability, when we are trying to find the probability that one event will happen under the condition that something already happened. Okay? So something already happened, or I already know something happened. So I need to find the probability of this happening, right? That's conditional probability. Okay. Okay, so here are the formulas. If they tell us that these two events, sometimes they'll say, hey, these two events are independent. They just straight up tell you. If they tell you that, you're going to use number 6. That one right there. The probability of A times the probability of B. Okay. About 90% of the time, they won't say. They will not tell you. So if they don't tell you, we have to use number 7. Okay, we have to use number 7. So what does that line mean? It looks kind of like a fraction, division symbol. What is it? It's neither. This is what it means. It means given that. Given that. So what is the probability of A given that B already happened? B's already happened. What's the probability that I pass this test given that I already studied last night? All right? That's what it's kind of saying. What is the probability given that, right? What is the probability you get an A in Math 2 given that you got an A in Math 1, right? It already happened. So something already happened that may or may not have impacted the probability that you're trying to find. Okay? So, like I said, number 6 we rarely use because that's the only time we can use number 6 is when we know for a fact they are independent. And how do we know for a fact they are independent? They'll tell us. They'll say these two events are independent. And they rarely say that. Most of the time, they want you to either check for independence, which we use this guy here, or we don't know. So if we don't know, we're going to use the general multiplication rule, which is right here. Okay. I probably should match the letters A and B here. They put A first and B second. So let me change that. Because the letters, the order does matter. Okay, all right. So now let's go back to this guy right here. If two things are independent, both of these are going to be the same fraction, the same decimal, the same percent. So what the first one says is, what's the probability of A happening given that B already happened? B's already occurred. What's the probability of A happening? That has to be equal to the probability overall of A. So if they're equal, it means B had nothing to do with A. If they're not equal, that means B did affect A, which means it's dependent. Okay, and we're going to do some examples of that today. Okay, so let's look at a problem here. Okay, so the first problem. I title these, the first couple I title by what we're going to use. Venn diagram, two-way table, tree diagram. In real life, on tests, on quizzes, on homework, they don't tell you which to use. They're not going to say, make a table, make a Venn diagram, make a tree diagram. So what we're going to kind of do is try to figure out what makes this a Venn diagram problem. Could we do a table? You know, sometimes you could do both. Okay, so Megan has applied to Cornell University and Purdue University. Okay. Suppose that the probability that Megan is accepted to Cornell is 40%, 0.4. And the probability that she is accepted to Purdue as 0.5, 50%. Okay. And then the probability that she gets into both is 20%, 0.20. And then we get to answer some questions. So I would do a Venn diagram for this problem because we have one event, another event, and then they told us what's the probability of both of them happening. So in my head, I'm seeing one circle for Cornell, one circle for Purdue, and then they overlap in the middle. Okay? So that's why I would use a Venn diagram for this problem. Okay? So to do a Venn diagram, let's see. We're going to make two circles. This Venn diagram has two circles at least. Sometimes it'll be three. Okay. Okay, so one event is she goes to Cornell. So I'm going to use a C for Cornell. One event is that she gets in, the other event is she gets into Purdue. You're going to use a P for Purdue. Okay. When you're doing Venn diagrams, start in the middle. Always start in the middle. So the middle is both. What's the probability she gets into both? 0.2. Okay. And then now, what's the probability? The probability she gets into Cornell is 40%. So do I put a 4 in the big one? No. I put a 2 in the big one because in the circle, there cannot be more than 40. In the circle, there has to be 40%. Not, if I put a 4 in there, that would be 60%. That's too much. Okay. And then in Purdue, it was 50%. So this guy over here is 0.3. I'm missing some. Yeah, I'm missing some, right? Altogether, I got 40 plus 30 is 70%. So I'm missing 30%. So that's going to be on the outside. What does that represent? There you go. There's a 30% chance she doesn't get accepted to either college. Okay. Okay, so what is the probability Megan is not accepted to either? Oh, they just asked that right there. 30%. Okay, so the probability she doesn't get into Cornell and doesn't get into Purdue is 0.3. Remember, the C means not. So probability P of C means she does. P, that little notation up there means not. So not Cornell and not Purdue. Okay. Mm-hmm. Could you also write this out like in words? Mm-hmm. In words too, yeah, for sure. Yeah. Words are okay as well. The only reason I use the symbols here is because they use symbols on multiple choice a lot. On multiple choice, they'll use these symbols a lot. So I write them down in the notes just so that you're used to them, to seeing them. Okay, it's not because I need to see them. You can write it in words, but I include them as much as I can because I want you guys to be familiar with them. So when you're on the test doing multiple choice, you know what those mean. Okay. Okay, so B, what is the probability Megan is accepted to Purdue, but not Cornell? So what is the probability she gets accepted to Purdue and not Cornell? So can we just look at the table and figure that out? Yeah, we could, right? Purdue, so let me color code this. So yellow is Cornell. The bluish color, the light blue, is Purdue. So they're asking Purdue, so blue, but not yellow. Blue, but not yellow would be 0.3. Okay. Because if it's 0.5, that's Cornell. We don't want Cornell. Okay. All right. Let's look at the next one. So you know what? Let me move down here so I can get a better. Okay. The next one says, what is the probability Megan is accepted to Cornell given that, right there, I'm going to underline that many, many times. That's your key that you're going to use the formula with the given that symbol, right? The line in the middle. That's the key that you're going to do that. Okay. Anytime you say given that, or they say, hey, something happened in the past. That's your key there. So what is the probability Megan is accepted to Cornell given that she's already been accepted to Purdue? Purdue already happened. Okay. So I'm going to write this. So what's the question asking? The probability of what? Cornell. That's going to go here. The question goes first. Whatever question they're asking goes first. That's what the question is saying, right? What's the probability she's accepted to Cornell? That's why that goes there. Okay. The first one addresses the question. The second one addresses what's the given that part. She already got into Purdue. Yeah. So we're going to put a P over there. The reason the order is important is because we're going to match the order on our formulas, right? The order of our formulas, right? So A is going to be C. A is in the C position and B is in the P position, right? Formulas, where's the formula? Right here, right? For our problem, C is here and P is there, right? So up here is going to be C and P, and down here is going to be P. That's exactly what I'm going to write down on this problem. So the top is both the probability of C and P over the probability of the given that part, which is Purdue. Okay. Now we have to fill in with numbers. What's the probability of both happening? And say it again. 0.2. It's the middle part, right? The middle part is 0.2. What's the probability of just Purdue? Yeah, for Purdue, we're looking at the blue circle. Purdue, it just says Purdue. It didn't say anything about not Cornell, right? It just says Purdue. Just Purdue in general. So that's 0.5, right? Go to your calculators. You'll get 0.4. I've been doing this. I taught this class. This is my 9th year teaching this class. And trust me, the one thing I've learned over the years for myself and for students is that you write that out exactly how I have it there. Because if you write it out, it keeps it clear in your head. Okay, so that number goes there, what you're looking for and what it's there. A lot of times people just try to do all of it in their head. You're bound to make mistakes somewhere because this is so abstract, right? It's hard. The math is super easy. Division, right? But the hardest part is, okay, what numbers do I divide? Keep it concrete, okay? All right, okay, so let's do the next one. So here we go, we have an independence problem. An independence, so they wanna know, are accepted to Cornell and accepted to Purdue independent of each other? So knowing that she got into Cornell, is that gonna change the probability that she gets into Purdue? No. See right there? Don't think about it. Use the formula. Because if you think about it, you're like, well, if she goes to college and one college says, then yeah, I think so. That's where you start getting into trouble, right? We want to check with evidence that we have. Okay? So what we're going to do here is you can do one of either two ways. All right? We can check Cornell given Purdue is Cornell. We can check that. Or, yeah, and we just did that one too, right? So we know the number, we know the answer to that one, right? Or you can switch them. You can say Purdue given Cornell is equal to Purdue. You don't have to check them both. You just check one of them, and if one of them is equal, they'll both be equal. If one of them is unequal, they'll both be unequal. So it doesn't matter which one you check. Okay? Well, didn't we just find, Aldrin said, didn't we just find this guy here? C, Kiv, and P, we just found that number, right? It's right there, 0.4. So let's use this one. Now, overall, what's the probability of Cornell? 0.4. So because they're equal, they are independent. They are. So sometimes it'll say justify your answer. Right here is your justification. This is your justification right here. Okay, that's your justification there. So that means knowing that she got into one college, is that going to affect her application to the other college? No, it will not. If you tell me, hey, she got into Cornell, is that going to change the probability that she gets into Purdue? Nope. It won't. It won't affect it. Right? And it kind of makes sense, right? Colleges don't talk to each other. They look at the applications they have here. They don't call, hey, Cornell, did you let this girl in? No, they don't, right? Okay? But that proves it. This shows that they are independent. Okay. All right. Two-way tables. Two-way tables. Okay. Two-way tables are another way to solve probability problems. Okay. Two-way tables are just like how you had for homework. Right here, right? You guys had to make two-way tables, right? Put numbers in there, totals and everything like that. Those are two-way tables. Sometimes they'll be nice enough to give you a two-way table. Most of the time they won't. You have to make one on your own. Okay. Just like we have to do on this one. Just like we have to do on the tacos problem. Okay, so free tacos. In 2012, the fans at Arizona Diamondbacks home games would win 3 free tacos from Taco Bell if the Diamondbacks scored 6 or more runs. In the 2012 season, the Diamondbacks won 41 of their 81 home games and gave away free tacos in 30 of their 81 home games. In 26 of the games, the Diamondbacks won and gave away free tacos. Okay. So sometimes they do this. If the team wins, they have little promos that say, hey, go over here and you get a free whatever. Okay. In 2012, they did this. Okay. So this is a classic two-way table problem because there's two variables. What are the two variables that we need to match up against each other?
I found this on the web.
What are the two variables that we're trying to match up to each other? Because we're going to make a two-way table. We're going to make a two-way table. Let me make one over here. Yeah, kind of looks like tic-tac-toe, yeah. It won't when we're done, but at the beginning it does. So what are the two variables that we are comparing in this question here? So tacos. What are the two options for tacos?
Yeah, they gave it away or they didn't.
Did we get free tacos or did we not get free tacos? Okay. And what's the other one?
Yeah, they won or not.
They won or lose. Yeah, they won or lost, right? Okay. So that's what we're going to measure. So over here, free tacos. No free tacos. And then over here, did they win or did they lose? Okay. On the inside, you can put raw numbers. Raw numbers are like 41, 26, 81, 30. Those are raw numbers. Or you can put decimals in there, right? You can put percents in there. Usually we'll do percents later. Usually we put raw numbers in here if we have them. Okay. So which one do I know? Do I know how many wins had free tacos? Do I know how many no free tacos and a win or a loss? They've given me some information, right? They said here. So we'll start here. They said the Diamondbacks won 41 of their 81 home games. There's some information there. So 41 of their 81 home games. So I know that they had 81 total. So we need to have totals here. You also, when you're doing two-way tables, you also need to have a totals category. So let's add that. Okay. Totals. So 41 and 81, where do they go? I need to fill in this with numbers. So I have, let's see, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, cells that I need to fill in with numbers.
41 is in total for wins.
41 is total for wins, right?
81 is total in the bottom.
Okay, so let's fill this out. So 41 total for wins. That's how many they won total.
Of 81 games.
81 is the grand total, right? The total number of games they had. So what can I fill out? I can fill out another box, which this one here,
Total of free tacos given.
this one has to be 40 because 41 plus 40 makes 81. Okay, so I know 40 games they lost. It didn't tell me in the question, but because I made a table, I can tell that. Okay. All right, so we got those two now. We're done with those two. Let's keep going here. Free tacos were given away in 30 of 81 home games. There's free tacos. The total free tacos was 30. That means in 51 of the games, there were no free tacos. Okay, and then they give us something in our last sentence here. They say
26 of the games.
the Diamondbacks won and gave away free tacos, right? So 26 goes in the won and free taco category. One free taco, 26 right there.
30 minus 26 is 4.
So that means in 4 of the games they lost, but they still gave away free tacos. How did that happen? How did they lose, but you still got free tacos? They scored a lot of runs, right? In baseball, the more runs you score, the better chance you have of winning. But occasionally, if you score a lot of runs and you don't play good defense, the other team will score more runs. Okay. Okay, so how about these other? I got 2 more cells that I need to fill out. Do I have enough information to fill them out?
41 minus 26 is 15. 40 minus 4 is
36. There we go.
Add them all together.
Yep. Always want to check everything to make sure everything adds up, that you didn't add wrong like I did in the on the homework. You always want to double check to make sure that all of them add up. Sideways, up, down, positive, or left, right, up, and down. Okay. All righty. Okay, so now B says find the probability of P, W, or T. So W is a win or free tacos. So it's saying, what's the probability that you win or you get free tacos? Okay, well, let's see here. I'm going to use my chart here. So that means win plus free tacos minus a win and free tacos. That's just the general multiplication rule, which is on the board, which is in your notes. Or sorry, general addition rule, because there's an or in there. So first of all, I got to find the probability of a win. What's the probability of a win? How do I figure that out? 41 out of 81, right? 41 out of 81, I'm going to change it to a decimal, which is 0.506. 41 out of 81. What's the probability of free tacos? 30 out of 81, right? Yeah. Which is 0.370. Minus the probability of both. How do I find the probability of both wins and free tacos? Yep. Find that box that happened. 26 out of what?
81.
81, good. Good, 81. We got 0.321. Okay, so just got to finish up that math. What do we get? 0.556?
Repeating. Round up to
56.
no, point.
Oh, no, 0. 0.556.
After rounding.
Perfect.
Is it okay if like I put like the repeating line over the 5, or would I have to?
That's fine. Yeah, that's fine. Is it 0.555555 repeating? Yeah, that's fine. Yeah, that's not a problem. Yeah, yeah, it's the same thing. All right. All right. So now let's look at the next one. Try those two. Try those two if you haven't already. C and D. They look the same, but they're going to be different. If you're stuck, look over here.
What did you guys get? Only I got 0.933. Yeah. Wait, now hold on a second.
So yeah, anytime you see a given that, a line in between, your brain should go right to here. I've seen that before. Where have I seen it before? Right there. Go back to there. Just take out the A and B and put in what you need to put in. And then go find it. Okay?
Tacos is 30. Wait, where'd you get 37 from? Oh, yeah, okay, now you're right there. Oops, I skipped a few steps. And then you got 70, right?
Okay, so the setup is here. They look the same because you see a bunch of T's and W's and you're like, oh, aren't they the same? They're not the same because you're dividing by a different number. You're dividing by T over here and you're dividing by W over here. Okay, so the probability of wins and tacos. Didn't we just do that one up here? Oh, that was or. Yeah. Wins and tacos is 26 out of 81, right? Which is 0.321. We did that over here. We actually did it. It wasn't our answer, but we did it within the question, right? And then this one, we're dividing by the probability of just tacos, which is 30 out of 81, which is 0.370. So we get 0.321 divided by 0.371 or 70 and I get 0.868. So given that, they get free tacos. Given that they get free tacos. We already know that they get free tacos. What's the probability they also win? Pretty high, right? Pretty high, because in order to get free tacos, you got to score a lot of runs. And in baseball, the more runs you score, the better the chance you're going to win. That's why that number is pretty high. 868. I get 8675. And then the other one, the probability of both is still 321, but now the probability of winning. Probability of winning is 41 over 81, which is 0.506. 0.634. That's fine.
Oh, it's 81.
Yeah. So yeah, here's the thing, real quick, and then we're done. Your decimals. Remember in chapter 2 when we did decimals, and some of you guys are off by a little bit. That's the same thing here because we're rounding, right? So the rounding is going to be off a little bit. Okay. All right. Okay. So remember the only assignment is from yesterday. So if you finish that assignment, upload it. If you haven't, it's due tomorrow. Okay. I'm not going to assign anything new today. All righty.
Where's my letter?